Okay, so today we are going to discuss the organic chemistry part. Uh, so here I will be going through the most important facts and trying to memorize the most important parts here, right? So when it comes to organic chemistry, so the main part, the main thing that you need to know is that you need to know how to give the naming of the organic compound, right? So in classes we discussed the how to get the name, like what are the components of the naming part, where you have the prefix value, root value, and the suffix names and all those stuff. So you know what I'm mentioning about here. So try to remember the steps and try to get the answers. And here the most important part is the remembering the functional groups, right? So if we are dealing with carbon-carbon single bonds, then those are alkanes, and if it is double bonds, then they are alkenes. And if you are having OH groups, then they are alcohols, and if it is carboxylic acid, this C double OH group, then they will be oic acid, right? Oic acid. So go through the note where I have mentioned about naming and those we did some activities as well to choose the functional group like us, right? So go through them. And then the most important part here is the uh, different type of formula, right? So empirical formula, molecular formula, you know what are the differences here, and the general formula is the generalized formula type that we can identify the type of the compound, right? Type of the compound, and structural formula. So it will be giving you the structure, and displayed formula will be something like this, where you can see the type of the bond likewise, right? Then we have crude oil section. So here I am just rushing through them. This session might be something like 30 minutes long or something like that, right? So here definitely you need to remember this fractional column thing, right? There were several questions from fractional column. So mainly crude oil will be heated, and it will be vaporized, and then it will be directed to the fractionating column. So here, remember at the bottom, so it will be around 400 Celsius, and here it might be 40 Celsius, which means like when you're going towards the top, the temperature decreases, right? The temperature decreases. So here in fractionating column, we extract the component depending on their boiling point, depending on their boiling point. Okay, so here refinery gases. Okay, so first we can get the refinery gases out of there, then gasoline or petrol, then kerosene, diesel, fuel oil, and finally the bitumen. So bitumen is the actual waste. So here it will be taken as a liquid, but these things will be taken as a gas component. Afterwards, we can convert that into liquid, right? So remember, bitumen is the waste material that is going to be at the bottom. And remember, so for bitumen, so the reason why you are getting the liquid is that their boiling point is somewhat higher than 400 Celsius. So still the temperature has not reached, right? So therefore, what will happen? It will be existing as a liquid, and we can easily get that liquid out of the column, right? And when it comes to physical trends, so here, when the carbon number increases, or when we are dealing with these things, so here we can see, yeah, this is given for these fractions here, right? So physical trends, the boiling point increases, right? And the viscosity increases. So viscosity here, it is mentioned as running to thick, which means like you know, like there's a difference between bee honey and water, right? So when it comes to bee honey, it travels very slowly on the surface. So but in water, it travels faster, right? Compared to that. So something like that viscosity. So you will learn about these things in A levels, right? And the color will be darkened when you go towards the bottom section, when you are going towards the bottom section. Then the energy releases, combustions, and the consequences. So here, when it comes to combustion, there are two types of combustion: complete combustion and the incomplete combustion. So for the complete combustion, there must be required amount of oxygen, right? Required amount of oxygen. So then you will be getting this carbon dioxide and water. So try to remember the equation if possible. So any sort of a hydrocarbon, when it is burned, then definitely you will be getting the products as carbon dioxide and water. So hydrocarbon, the carbon will be here and hydrogen will be here, right? So these are the two products, carbon dioxide and water. So this is for the complete combustion, right? This is for the complete combustion. But when it comes to the incomplete combustion, right? So here we are dealing with limited oxygen, right? Which means there won't be sufficient oxygen amount, but so still it will be burned, right? Still it will be burned and resulting carbon monoxide, carbon, and might be some water vapor as well, right? But mainly we focus on carbon and carbon monoxide. So here you can see if it is the complete combustion, then you will be getting this blue colored flame, right? Blue flame. But if it is the incomplete combustion, then you will be getting something like this, right? Some bright yellow or orange color flame with this unburned carbon here, this soot actually, that is the ash there, right? The remaining ash. So toxicity warning is given there. Carbon monoxide burns through red blood cells, preventing them from carrying oxygen, leading to breathing difficulties and death. So here in red blood cells, we have the hemoglobin uh, pigment, right? So it can bind with oxygen, but when carbon monoxide bind with it, the reversibility of that reaction decreases. So for example, if it is with oxygen, so this will bind with four oxygen molecules, a reversible reaction, and you will be getting HbO8. So reversible reaction means this HbO8 product can be easily converted to or broken into hemoglobin and oxygen, right? It can be going in either ways. But if it is bind with carbon monoxide, then you will be getting HbCO. So this is a one-way reaction. So therefore, from HbCO, you cannot convert back into hemoglobin. So which means eventually the amount of hemoglobin will decrease, right? The amount of hemoglobin will decrease. So therefore, the amount that can capture oxygen will decrease. So therefore, it will lead to breathing difficulties and eventually for death as well, right? So this is the reaction. No need of writing the reactions, but try to get the idea, right? If they are asking what are the reactions, then you can write the reaction. But I think they are just asking what will be the health effect or the toxicity effect caused by the carbon monoxide. Then just you can write this answer. No need of writing the reactions. And the impurities and the environmental impact is also given, right? So if we are having nitrogen oxides, NOxes, and also sulfur dioxide, so we discussed about these things. So then they will be dissolved in water and eventually they will cause in acid rains as well. Even in classes, I have given the reactions as well. So please go through them and try to memorize what we have done there, right? Then the thermal decomposition via catalytic cracking. So here graphical representation is given, right? So when it comes to long chain alkanes, there's a high supply, but the demand is low, right? But when it comes to short chain alkanes or plus alkenes, these are the products after the catalytic cracking. So here we are having a low supply, but with a higher demand than the long chain alkane. So in order to balance this, we are using the catalytic cracking. So from catalytic cracking, what will happen? The long chain alkanes will be broken into short chain alkanes plus alkenes, right? Short chain alkanes plus alkenes. So these are the guys having a high demand, right? So here we have given uh, some sort of a flow chart. So here you can see long chain hydrocarbon vapor. So then we are using these strict conditions, heating up to 600 Celsius to 700 Celsius over hot silica or alumina catalyst, right? Alumina catalyst. No need of writing the exact chemical compound, chemical formula for silica or alumina. Just write the term. Then you can still get the marks there, right? And in the groups, I think I have uploaded that catalyst table as well. I'll upload that once again. Okay. So here shorter chain alkanes with a high demand for fuels and unsaturated alkenes can be used for plastic generation, right? Plastic in order to make plastic. And then we will discuss about alkanes. So they are known as the saturated hydrocarbons, right? Saturated hydrocarbons. So saturated means each carbon atom occupied with four single bonds, right? Four single bonds. So this is the saturated carbon atom, right? So always remember carbon should make, right? It is a must, right? Carbon must make four bonds. So it can be either single bonds like this. I'll draw it in another place. It can be either like this, or you can have a double bond and two single bonds like this, or you can have a triple bond and like this, right? So these are unsaturated, but this is saturated, right? Saturated versus unsaturated. So remember that. And here a homologous series. So you should know what is meant by a homologous series. And even in the question papers, they have asked that question, right? Homologous series is a series of compounds where you are having the same functional group, right? Where you have the same functional group, but different number of carbon atoms there, right? So here the general formula is given, right? Containing single CC bonds. So here the naming and the formula are given there. No need of remembering the formula, but remember how the name changes when it comes to the number of carbon atoms, and their reaction mechanisms are given. So there's only one reaction mechanism, a substitution mechanism. So substitution means you are removing one, and in the meantime you are taking one, right? So here requires ultraviolet radiation. So here you need UV energy. So once UV is present there, then this sort of a reaction can be done, right? Okay. Then about the alkenes, so they are falling under unsaturated carbon compounds. So alkenes means you are having the carbon-carbon double bond, right? Carbon-carbon double bond, and the general formula is also given, right? The general formula is also given. So ethene, propane, propene, butene, likewise. There won't be anything called methane, right? So just having a single carbon atom, you cannot make a what do you call a chain of carbons, right? So therefore, the minimum number of carbon atoms required is two. So then you are starting from the second carbon atom, right? So here the reactions are given. The reaction mechanism is addition. So substitution versus addition. So addition means you are just adding one without removing anything. But in substitution, we are removing one, and instead of that, you are adding a component. So here there's a reaction given. So this will be the product. Okay. And identifying the saturated versus unsaturated bond, right? Identifying saturated versus unsaturated bond. So when it comes to functional group, alkanes will be having just that carbon-carbon single bond, and for alkenes, it is going to be the carbon-carbon double bond. And the reaction type with the halogens, so for alkanes, it will be substitution, and for alkenes, it will be addition. And in order to separate these alkanes and alkenes for single bond and the double bond, we can use this bromine water test, right? This bromine water test. So bromine water is a Br2 liquid, right? Br2 liquid. So here, initially this bromine water is in orange color, right? It is in orange color. So once it is added to an alkane, the orange color will be persistent, like it won't change. But once it is added to alkene, this orange color turns to colorless. The reason is that it will continue with the reaction. So here we can see this is going to be the Br2 liquid, the bromine water thing, right? So this is having the orange color, right? So once an alkene is added, the reaction will go and this bromine molecule will be dissociated. It will be broken. So therefore, there won't be any bromine liquid molecules. So therefore, the color will be turning into colorless, right? So that is the main theory here. So remember this test. So this test can be used to identify or to separate alkane with an alkene, which means carbon-carbon single bond separating with the carbon-carbon double bond. So for you guys, there's nothing mentioned about the alkynes, which is the type of compounds that you have carbon-carbon triple bonds. But so this thing can be used to identify the unsaturated bonds, which means like it can be even used to identify the carbon-carbon triple bond as well, right? So, but for you guys, it is only the separation between the single bond and the double bond. That's all. So therefore, no need of knowing the other ones, right? Then about the alcohols. So alcohols are the guys having this OH functional group, right? So manufacturing ethanol. So this thing, a flow chart is given, right? So there are two methods, hydration and fermentation. So there are some conditions that we can use, right? So there are two methods that we can use to manufacture ethanol. So please go through it. And here some of the ethanol molecules are given there. And oxidizing ethanol, so if it is complete combustion, then you will be getting carbon dioxide and water. And the second one, microbial oxidation, so then it will be making ethanoic acid. And if it is being heated with potassium dichromate, then you will be getting ethanoic acid there. And there's a special point here, this potassium dichromate, right? So this is actually orange in color, right? Orange in color. So once the reaction is done, this thing will be turned into yellowish color. The reason you will be getting chromate ions. No, it will be turned into green color, right? This thing will be turned into green color. The reason you will be getting Cr3 plus ion. No need of knowing this part, but remember once the reaction is done, this orange color potassium dichromate will be turning into green. So in this section, we are dealing with two experiments where we have to deal with colors, right? So the first experiment is this bromine water test. So bromine turns to colorless. Then you have an alkene, and the second one, orange color potassium dichromate, it will be turning into green color when it is being reacted with an ethanol molecule, right? Ethanol molecule. So remember those points. And here about the carboxylic acid group. So carboxylic acid, this part. So you can write it like this, even, right? And also, if it is written like this, CO2H, still they are the carboxylic acid. So nothing changes here, just one carbon atom. So therefore, methanoic acid. So when you are naming it, just you need to add oic acid part. That's all. So if it is just one carbon atom, methanoic acid. And if it is two carbon atoms, ethanoic acid. Three, propanoic acid. Four, butanoic acid. Likewise, easy, right? And here the reaction behaviors are given. So there are some aqueous properties, and also they can be reacted with metals as well, and also can be reacted with carbonates as well. So the reason is like these guys are having some acidic features. So therefore they can be reacted. And the next one is the esterification reactions where we are forming esters. We are generating esters. So in order to make an ester, so this is the common reaction. You need to react a carboxylic acid with an alcohol. So acid catalyst is being added. So most of the time we will be using sulfuric acid as the catalyst. Then we will be getting ester and water. So here, remember, so this molecule will be broken, right? Molecule will be broken, and there will be a water molecule formed, and well as the ester molecule as well, right? So properties and naming of rules. So you can go through it and get the idea of naming the esters, right? And the polymers. So we know what is meant by a polymer, right? Polymer is a a combination of monomers. So monomer means the smallest unit. So you are adding those smaller units together, and in order to make a huge unit, right? So thousands of small alkene molecules known as monomers join up to create a massive macromolecule named the polymer. The repeat unit, right? The repeat unit contains the exact same atoms as the monomer. No byproduct is formed. Byproducts means the other products that can be made rather than the main product, right? So here some of the polymerization reactions are given there, but in the classes I gave you a table, so please refer the table, right? There's a small table which I have made, right? There we have the polymer, monomer, as well as the repeating unit as well, right? So remember that one. And please go through the table as well. And the condensation polymers. So when it comes to condensation, so polymer, the creating of polymers, like there are two methods. The first one is addition, right? Addition, you are adding molecules and there won't be any sort of a byproduct. But the second type of making polymers are the condensation polymers. So condensation means you are getting a water molecule as well, right? You are getting a water molecule as well. So most of the condensation polymers in your syllabus, we will be discussing about forming the esters. That's all, right? So we are forming the esters. So in order to form an ester, you will be needing a carboxylic acid and you will be needing a carboxylic acid and an alcohol part, right? So here you can see diol. So diol means you are having two OH parts at the ends. That's why di means two, right? Di means two. Diol, two OH parts, right? And dicarboxylic acid. Once again, di means two, and here two carboxylic parts at the end, right? So these two will be combined and will be making a chain structure that will be known as polyester, right? If it is just one, then it is ester, but it is a now polymer, so therefore it will be a polyester, right? And so those are the main important things that we need to discuss. So please refer the notes and go through the summarized notes and all the stuff that I have given you guys, right? Okay, so is there any questions from this section? I just rushed these things. So the reason is like now it is 28. So next week you will be starting your exams. So I don't want to spend more time on repeating myself about the things that we have discussed in the classes, right? Yes. So please go through the polymer section, right? Polymer section. Easily you can get marks for organic chemistry from the polymer section. They are very easy. Like the same thing they will be asking again and again, right? So please go through the notes and yeah, the most important thing is the identification test, the bromine water test and the potassium dichromate test, right? So then if there are no questions, then I can wind up the session, the organic chemistry part. So that's why I mentioned, so this will be just 30 minutes or 20 minutes long session, right? Okay, so if there are no questions, we can write down the session. So I will start the physics session at 11 a.m. So there I will be discussing. Again, I will be rushing through the things, just memorizing the stuff for astrophysics. And also I left that part where we have discussed about momentum and the turning effect. So in that class, we will be discussing those three theory parts and will wind up the revision seminar series at 11 a.m. Okay. So if there are no questions, then we can wind up the session. So please utilize this time, go through the questions and try to figure out uh, the try to revise yourselves, right? So go through the question paper. So still like you are having just a week or something like that. So please go through them and try to give your maximum effort in this manner, right? Okay, so I'll wind up the session and thank you for joining.